Welcome to The Explainer. Today, we're going to pull back the curtain on science itself. We're talking about the blueprint, the actual plan every researcher uses to turn a simple question into a powerful, reliable study. Let's dive in. Every big discovery starts with a question. But what separates a wild guess from a real scientific breakthrough? It all comes down to the process you build to find the answer. And that process, that's called research design. And this analogy, it's pretty much perfect. Imagine you're standing in a totally empty room. Before you even think about buying a couch or picking a paint color, you have to decide what the room is even for. Is it a kitchen? A bedroom? A workshop? That one decision changes everything that follows. And research is exactly the same way. So, let's go back to our empty room. Your very first decision is all about the goal. What are you actually trying to do here? In the world of research, your purpose is almost always going to fall into one of three main categories. First up, you've got exploratory studies. Think of these like expeditions into totally uncharted territory. You've got a hunch that something's out there, but there's no map yet. Your entire goal is just to ask the most basic question: what is even going on here? So let's say you're curious about the stigma around mental health for teenagers. If nobody's really looked at that specific link in that specific age group before, well, your study is exploratory. You're literally the one drawing the first draft of the map. Okay, next are descriptive studies. So if exploratory research draws the map, descriptive research, well, it fills in all the details. The goal here isn't about finding some brand new connection, but about painting a really rich, vivid picture of something we already know exists. It's all about answering how. A perfect example of this would be a study looking at the day-to-day lives of undocumented immigrants. We might have some statistics, right? But a descriptive study gives us that rich human detail of how they actually find jobs, how they build communities. It really brings the numbers to life. And finally, there are explanatory studies. You use these when you already know two things are connected. We know A is related to B. We just have no idea why. This is the design that tackles that huge, all-important question, why? We've seen for a long time that there's a link between substance abuse in a family and the kids later using drugs themselves. An explanatory study would dig in to figure out the why behind that pattern. Is it about economics? Is it about depression? Is it something else entirely? This is how we move from just seeing a connection to actually understanding it. Okay, so once you know your goal, whether you're exploring, describing, or explaining, the next huge decision is about your timeline. Are you going to take a single snapshot in time, or are you in this for the long haul, filming a whole movie? It really boils down to two options. A cross-sectional study is kind of like taking a photograph. It's one single snapshot of a group of people at one specific moment. A longitudinal study, on the other hand, is more like shooting a movie. You collect data from the same people again and again over time to see how things change. But here's the really crucial trade-off, especially with those snapshot studies. Their biggest advantage is, yeah, they're fast and they're cheap. But that exact same feature, getting all your data at once, is also their biggest weakness. You see a moment in time, but you can never be sure what came first. And that means you just can't prove that one thing actually caused another. And that brings us to what is often the holy grail of research: causality. Proving cause and effect is one of the absolute trickiest things to do. Just because two things seem to happen together, it doesn't mean one is causing the other. Let me ask you a kind of ridiculous question. In the summer, right, ice cream sales go way up. And so do sunburns. They are absolutely correlated, but does that mean your pint of ice cream is literally giving you a sunburn? Of course not. But this perfectly shows a classic trap in research. This is what researchers call a spurious relationship. It looks like a connection, but it's basically an illusion. There's a hidden, third variable lurking in the background, in this case, hot weather, that's causing both things to happen. The ice cream and the sunburn aren't affecting each other at all. So, to officially prove a cause and effect relationship, you have to pass this really strict three-part test. No exceptions. First, the two things have to be correlated. Okay, check. Second, the cause has to happen before the effect. Makes sense. And third, and this is the tough one, you have to prove the relationship is non-spurious. You have to show there's no hidden hot weather variable messing with your results. So if a simple survey can't prove that one thing causes another, how do researchers ever do it? Well, they have to design a study that can control for all those other factors. And for that, we turn to the gold standard, the experiment. A true classic experiment has these three essential ingredients. You have an experimental group that gets the thing you're testing, like a new drug, and a control group that doesn't. You randomly assign people to those groups so you know they started out roughly the same, and then you test them before and after to measure the actual change. It's that structure that lets you isolate the real cause. But researchers have ways to get even more rigorous. I mean, think about this. What if the simple act of taking the first test actually changes how people behave later on? This incredibly clever setup, the Solomon four-group design, solves that. By adding two more groups that skip the pretest entirely, you can actually measure the effect of the test itself. It's a brilliant way to make your results even more rock solid. So there you have it. Whether you're exploring new territory or explaining a known link, taking a quick snapshot or filming a whole movie, these are the fundamental blueprints that turn simple curiosity into real science. Now that you know the toolkit, the only question left is, what mystery would you try to solve?